Meet Becky. She is the perioperative director at Riverview Health, and this lands in your inbox before her 2 o'clock operations meeting. Here is her email. As you read it, listen for 3 things: what feels urgent, the decision Becky has to make, and the first question the data can answer. The opinions about staffing, turnover, and surgeon arrival are context, not findings. Becky asked about first cases, but this file does not identify room or case sequence. Our first answerable question is what the arrival to start wait pattern looks like across all operating room cases. She does not want a dashboard yet. Read this like you are on my analyst team. Separate the background noise from the decision and the first answerable question. That is the work before we open Excel. Use the download button on the screen if you want to work through the exercise in the Class 1 Excel workbook. Before we get into the case, I want to back up for a minute and show you where we are. This is the first core class after the prep work. We're starting with how to frame a problem because everything else in the course sits on top of that. Excel and Tableau will do exactly what we tell them to do. They won't tell us whether the question was any good. So that's where we are today. In Class 2, we'll follow the healthcare work that creates the rows. Today, we're staying one step earlier. What are we trying to learn and why? The big idea is simple. Analytics should help somebody make a better decision. If it doesn't, we may just be making numbers. You are going to see this 3-part framework throughout the course. First, orient your thinking. What's the decision? How does the work actually happen? What are we asking, and how would we measure it? Then explore and understand. This is where we look at the pattern, the variation, the comparisons, and the things we're still not sure about. Then translate it to action. What does the evidence actually support, and what should the person responsible for the work do next? Today, we're mostly in that first part. We're getting the question straight before we start analyzing. Here's what we're doing today. Our first answerable question is, what does the arrival to start wait pattern look like across all operating room cases? This first pass is descriptive. We need a clear picture of what is happening before we start guessing about why. By the end, you will use a problem frame and a histogram to write Becky a short first read email. What the pattern shows, what it does not establish, and what to investigate next. We will also let AI poke holes in our thinking. Then we will go back to the real fields, the real calculation, and the actual table to see whether any of its suggestions hold up. Here's the framework I want you to use for this. Start with the concern. What feels wrong? What is suddenly urgent? This is the moment to listen before anyone reaches for a chart. Then write the first question the data can actually answer. What do we need to learn about the wait pattern before we explain it? Finally, name the decision the answer will support. Becky needs to choose the next investigation, not jump straight to a staffing or scheduling solution. This sounds basic, but it prevents a common problem: answering whatever is easiest to measure instead of answering what the team needs. If your first thought is a dashboard, a chart, or a metric, just back up and ask what decision that thing is supposed to help with. Before we go on, what would you try first? Becky says operating room starts are taking too long. What would you do first? Would you suggest adding rooms, compare surgeons, name the first question this file can answer, or build a dashboard? Go with the move you would honestly make first. This is not graded. After you pick, I will show you the assumption that yes. Turn the concern into the first question this file can honestly answer, then connect the answer to Becky's decision. Now, healthcare improvement is almost never about making one number better. The triple aim is a useful way to keep the larger job in view. We want to improve the experience of care. We want better health across the population. And we want to use resources responsibly, which the triple aim describes as reducing per capita cost. The important part is that we are pursuing all 3 at the same time. You can make a process faster and make care less safe. You can lower cost and make access worse. So even though our operating room measure looks like a simple clock, we still have to ask what else could move when we push on it. Let's bring that down from the health system level to this actual project. For Becky, the aim is more reliable operating room starts. She wants to reduce waiting that does not need to be there and use the available capacity well. The counterbalance is safe preparation. If the team gets faster by rushing something the patient needs before the procedure, we didn't improve the process. Those 2 things have to stay together. And just to be clear, The counterbalance isn't a fourth part of the triple aim. It's a practical safeguard for this project. Whenever you set name, ask what the team might accidentally damage by chasing it too hard. This next framework is one I come back to all the time, the analytics maturity curve. As you move from left to right, the analysis usually gets more complex. As you move up, the potential value of the decision can increase. Potential is the important word there. More complex work is not automatically more useful. Descriptive analytics asks what happened, or what is happening right now. Diagnostic analytics asks why it happened. Predictive analytics asks what is likely to happen next. And prescriptive analytics asks what we should do about it. People love to jump up this curve because prediction and prescription sound more advanced. I've seen that go badly more times than I can count. Becky asked, what is going on? So we start there. If we don't have a decent picture of what happened, anything we tell her about the cause or the solution is already on shaky ground. Before I use mean, median, and mode as if everybody already knows them, let's slow down and build the idea. All three are ways to describe the center of a group of values. The formal term is central tendency. Picture 10 people sitting in a Starbucks. Their salaries run from $45,000 to $85,000. Together they make $650,000. Nothing exotic is happening in this room. The mean adds all 10 salaries and divides by 10, which gives us $65,000. The median orders the salaries and looks at the middle. The two middle values are both $65,000. The mode is the value that appears most often, which is also $65,000 here. Now one billionaire walks in. Same room, one new observation. The mean jumps to about $91 million because it uses every value. That answer is mathematically correct and practically terrible as a description of the typical person in the room. The median stays at $65,000 and the mode stays at $65,000. That is the point. Mean, median, and mode all describe center, but they react differently to unusual values. Do not ask which one is best in general. Ask which one honestly describes this distribution for this decision. A percentile is related, but it is not another kind of average. A percentile marks a position after we order the values from low to high. The median is the 50th percentile. Here are the 11 Starbucks salaries in order, including the billionaire at the far right. For this 11-person example, the 70th percentile position lands on the 8th ordered value, $75,000. About 70% of the room is at or below that cutoff. When a requested position falls between two observations, Excel may interpolate between them. Now translate that to Becky's operating room data. A 95th percentile of 84 minutes means roughly 95% of weights are at or below 84, and the highest 5% are above it. It does not mean the longest wait. The observed maximum is 314 minutes. All right, here's the first table we have. It's simulated operating room encounter data. Each row is one operating room case. That is what one row represents in this table. If you lose track of that, it is very easy to count the wrong thing. We can calculate the time from operating room arrival to procedure start. That gives us a usable measure. It doesn't tell us why the time was long. There are 2,700 cases. Recall what the summaries mean. The median is the middle ordered wait, 34 minutes. The 95th percentile cutoff is 84 minutes. So now we can tell Becky something real about the pattern. We still cannot tell her what produced it. Keep both of those things in mind as we move into Excel, what one row means and what this table cannot tell us. Now reproduce the real first row calculation you will use in the actual workbook. On OR cases, the first arrival is in E5 at 7:53 a.m. and procedure start is in F5 at 8:29. Subtract arrival from start and multiply by 1,440 because Excel stores time as part of a day. The result is 36 minutes. Check it by hand, then sort the full weight column from largest to smallest. The maximum is 314. Filter above 60 minutes and you should find 302 cases above 142 cases. The class summary uses 60 minutes or longer, so it also includes the 12 cases equal to exactly 60 and shows 314. The calculation and the long wait checks add evidence without changing what one row represents. One row still means one operating room case. The short Excel walkthrough shows the full move in the real workbook. Start with one row, build and mentally check the formula, then sort. Start on the Explore worksheet, Select the blank result, cell G23. Build the formula in G23. Subtract arrival in G21 from procedure. Start in G22. Multiply by 1,440 and round to one decimal. Check one row before trusting the column. 753 to 829 is 36 minutes, and Excel should also return 36.0. Now open OR cases and select the first value in wait minutes. This column contains one calculated wait for each OR case. Open the filter arrow beside wait minutes. Find sort largest to smallest in the menu and choose it. The first value should now be 314 minutes. That is the maximum used in the class summary. Open the filter arrow again, choose number filters, then greater than. Enter 60 inches the greater than box and choose OK. Excel should report 302 records. This is strictly above 60, so it excludes the 12 cases equal to exactly 60. Open number filters and greater than again. Replace 60 with 120, then choose OK. 42 records should remain. You have built one calculation and checked. Let's reproduce the real first row calculation. On OR cases, arrival is in E5 at 7:53 a.m. and procedure start is in F5 at 8:29. Subtract arrival from start, multiply by 1440, and round to one decimal. The result is 36 minutes. Now move from one row to the full file. Sort wait minutes from largest to smallest and confirm the maximum is 314. Filter above 60 minutes, and you should find 302 cases. The class summary includes 12 cases equal to exactly 60, so its 60 or longer group has 314. Above 120, you should find 42. Those checks connect the cell calculation to the distribution without changing what one row represents. One row still represents one operating room case. Repeat the same moves in the Class 1 workbook linked through praxable.app. Here is what I would tell Becky from this first pass. Start weights vary across the 2,700 simulated operating room cases. The median is 34 minutes, and a smaller number of cases sit near the high end. I wouldn't say staffing caused it, I wouldn't say scheduling caused it, and I definitely wouldn't start blaming individual people. We don't have the workflow context for any of that. Take the three statements on the screen and sort them into what we can say now, what we cannot say yet, and what would be useful to ask next. Try not to fill in a cause just because it sounds plausible. The table shows 2,700 cases and the weight distribution directly. The table has timing data, but it does not have the workflow context needed to assign a cause. It takes the descriptive work one step deeper without pretending we already know the cause. This is the first time AI shows up in the course, so I want to be clear about how I approach it. AI is a tool. People bring a lot of big feelings and philosophy to it. In this class, we are going to learn how to use the tool well and where it can fail. I have seen people do better, more thoughtful work when they actually engage with it. It can help you think deeper by surfacing assumptions, alternatives, and questions you did not see on the first pass. It can help you go further, faster. It can organize a messy first pass, extend your analysis, and help you explore an idea without spending an hour staring at a blank page. And it can help you check yourself. You can ask it to challenge the math, the logic, the wording, or the assumptions you may have missed. But this is not an excuse to stop thinking. If you hand your judgment to the tool, you are using it badly. AI can give you more to work with. You still own the question, the verification, the conclusion, and the decision. Now let us put that into this case. AI is only as useful as the context you give it. You do not need a 15-part prompting formula. For most work, start with three things. First, give it a role. In this case, I want a healthcare operations analytics reviewer. I am not asking it to be an oracle. I am asking it to help me strengthen a first question without inventing causes. Second, give it the context that matters. Attach Becky's email. Tell it who Becky is, what decision she has to make, what measure we built, what evidence we have, and what this descriptive analysis cannot support. Third, name the task and the check. Do not just say, analyze this. Tell it to identify assumptions, recommend one useful next question, explain why, and list the workflow or data facts that still need verification. Here's what that looks like as one prompt. Notice how much of its usefulness comes from the context. It knows Becky's role and deadline. It has the email. It knows the row count, the weight definition, the maturity boundary, and the causes we have not proven. Then it gets a specific job. The AI might give you a strong next question. It might also assume a field exists when it does not, misunderstand where an event happens, or make the conclusion sound more certain than the evidence. So you verify the workflow, the fields, the calculation, and the wording before anything goes to Becky. Now pull this together into the problem framing sheet. The concern is already there. Now choose the first question this all case file can answer and the decision Becky can make from that first read. Some wrong options are tempting on purpose. If you jump to a cause, a forecast, or a solution, I will show you where the jump happened. The guardrails stay visible. Describe without blaming and protect safe preparation. When the question and decision fit the concern, you will see the three-part decision frame you built. Start with the concern. Operating room starts feel slow, and teams want an answer. Next, name the first answerable question. What does the arrival to start wait pattern look like across all operating room cases? Finally, connect the answer to Becky's decision. Choose what the team should investigate next. The guardrails remain clear. Describe the pattern without assigning a cause, and do not weaken safe clinical preparation. Those three moves give Becky a decision frame she can use. Pause at the framework we started with. This is a checkpoint, not the end of the class. We started with a vague concern that operating room starts felt slow. We turned that concern into a descriptive question. What does the arrival to start wait pattern show? The question supports a decision. Becky can choose what the team should investigate next. The project aim is still more reliable flow, and safe preparation is still the guardrail. The frame now holds together, but we still need to build and check the evidence. We now have a defensible question and a clear evidence boundary. One last move will make the first read more useful. See the full distribution, then write the evidence back to Becky. This is the first histogram in the course, so let's make the construction almost painfully simple. A histogram is built one observation at a time. Take one observation. This wait is 23 minutes. Choose the numeric bucket it belongs in. 23 lands in the 20 to 29 minute range. Add 1 to that bucket's count. That is it. Observation, bucket, plus 1. Repeat the same move for every value. These 7 weights become 4 bucket counts, and the counts become bar heights. The horizontal axis shows the ranges. The vertical height shows how many observations landed in each range. When we do this across all 2,700 operating room cases, the overall shape becomes visible. Now use that observation bucket plus 1 idea on the real operating room weights. The first 6 bars use 10-minute ranges. The final 60-plus bar is an overflow bin that groups every longer weight together. Recall the summaries. The mean uses every weight and is 40.3 minutes. The median is the middle case at 34 minutes. The 95th percentile cutoff is 84 minutes. Those summaries still do not show where the weights cluster or how many cases waited much longer. Now the fuller picture is visible. Each of the first 6 bars covers 10 minutes. The final bar is different. It combines all weights from 60 minutes through the observed maximum of 314. Most weights sit below 60 minutes, but 314 cases are in that overflow group. Those longer weights pull the mean above the median. Analysts call the thinning group on the right a right tail. The overflow shows how many cases are in that group, but it hides the detail inside it. If you need that detail, remove the overflow. Let's build this in the Class 1 workbook. Open or Cases. Click the first weight value in H5, then press Ctrl, Shift, down arrow to select the rest of the column. The status bar confirms 2,700 values. Choose Insert Statistic Chart, then Histogram. Excel builds the chart from the selected weights. Click the horizontal axis, then open Format Axis. Under Axis Options, keep Automatic selected for this first read. Excel will choose the bins and keep the long weight detail visible. Select the generic chart title and replace it with OR Arrival to Start Weight Distribution. Now read the center, spread, and the smaller bars on the right, where the longer weights appear. This native chart keeps that detail visible. The simplified class summary group. Now turn the analysis into something Becky can use. A strong email is short, but it does 4 jobs. First, state the evidence. We reviewed 2,700 simulated OR cases. The average wait is 40.3 minutes. The median is 34, and the observed range is 12 to 314 minutes. Second, describe what the histogram adds. About 74% of cases fall between 20 and 49 minutes, but 314 cases, or about 12%, are 60 minutes or longer, and 42 exceed 120. Most cases cluster near the middle, while a smaller group waited much longer. Third, be direct about the limitation. This file does not identify the room or which case was first, so this is an all-case baseline, not a validated first case analysis. Finally, give Becky a useful next step. Add room and case sequence, compare true first cases, and then gather workflow context before attributing the pattern to staffing, turnover, or surgeon arrival. In learner mode, write these 4 parts in your own words, then save the same note on the workbook's Becky note sheet. The download button is on the screen. Now we can close the loop. Analytics starts with a concern, but it earns its value by helping someone make a responsible decision. Becky's concern was that operating room starts felt slow. We reframed it as a question this file can answer. What does the all-case arrival to start wait pattern show? The answer supports Becky's next decision. Choose what the team should investigate next without pretending we already know the cause. We oriented our thinking by getting clear on the concern, question, decision, and evidence boundary. We explored and understood by calculating one weight, checking the full column, summarizing the center and high end, and reading the distribution. We translated the evidence to action by writing the pattern, the limit, and the next useful step in plain language. In Class 2, we move closer to the healthcare work. We will follow what created the rows and verify what one row represents before trusting a count,